All right, so basically you're going to get two viewpoints today. Some of you may have taught in-service teachers in a math for elementary schools classroom type thing and different things. Michelle has done that. He's taught math teachers in the classroom, graduate level classes and in-service classes. I have done professional development with teachers who really don't want to be there. So, you're going to get kind of two viewpoints as we go on. So here's what we hear all the time from the teachers. When we first start, they don't like me very well when I come in the room. So for example, I tried that once, but it didn't work. I'm not going to do it again. I don't have time to plan those lessons. My students don't like it. What's another good one? This will never work with my students. That one is so popular. This will never work with my students. Maybe yours, but not mine. So this is what I'm dealing with when we come in. All right, so these are kind of the components that we both kind of decided works well in both the classroom setting and in a professional development setting. We go through the pedagogy because if they don't see that this has been used somewhere else, they think it's just a trend, it's going to be gone next year, I don't have to do this. Then we like to do activities with the teachers that kind of model what the students are going to feel, same as we do here. You get a problem and they need to feel frustrated. They need to, get excited when they discover something. And so, we don't only give them the lesson plans for their students, we give them stuff that's at their level, challenging for them. And then the last one is to kind of recognize what does an IBL lesson look like? Because a lot of times they'll say, well, I do that, and then they'll show you something, and all it is a game, a memorization game. Or, and plus they've got to have some confidence that they can do this themselves. They don't have to go buy a bunch of products. Okay, so a little bit about the pedagogy. These are some articles. This article was given to us by some people who are working on Common Core right now. So I needed some newer stuff. I wanted as new as we could get. So this is what they gave us for new. I haven't really had a chance to go through it yet. I like this one a lot. What middle schoolers say about their schoolwork. I love that one. Because it really gives you a perspective for the teachers of what their students think about their classroom in different learning styles. And this one doesn't deal with mathematics. It actually deals with a language course. But it shows the teachers that their attitudes, that negative attitude we saw at the beginning, really affects how their students see, how they learn. Okay, so if they come in there and say, I don't want to do this, here, they said we have to do this curriculum. Do that activity. The students aren't going to do anything. But if they come in there excited about a problem, their students pick up on it, and we know this kind of thing. All right, so now I'm going to hand it over to Michelle about feeling the pain of the students.
My purpose was to design something that the teachers that would focus the teachers' concern on the same problems that their students have. How the teachers have known how to multiply and add numbers and carry for years and years and years. But I want to give them an idea of what their students themselves experience. So I've made some modules. And I want to, with my modules, I want to model the IBL teaching. As I indicated, I want to present these exercises so that the teachers can experience the same challenges and frustrations that their students have that are supposed to be challenging to the students. I'm going to ask the teachers who are my students, so I tend to call them students, to present their solution strategies, to find different solution strategies and to share them. And the one module that I have worked with successfully last summer and again this summer is a problem that I called some problems about cups and quarts. Everybody knows there are 4 cups in a quart, 4 quarts in a gallon, and so I made up some others. Let's pretend like there are 4 gallons in a box and 4 boxes in a pallet. So there's my scenario. Farmer Brown's Dairy sells milk in these various quantities. Those are the quantities that they have to use. And so the challenge to the teachers is you're to do all the problems without using those symbols. You guys know what I'm doing, and some of them know what I'm doing too, and I tell them I'm doing that on purpose. They're used to carrying when they add up to 10. Well, I want them to see what it's like to carry when they add up to something different. And many of them are used to cups and quarts. They've done cups and quarts for years. All right, so how do I address it? Well, sometimes something's going to come up, and they know that a quart is 4 cups. So I allow them to use the English language, which incidentally we do as well. When we talk about 11 or 12, we don't say 2 teen or 1 teen. 11 and 12, those are actual numbers that are a little bit different than the usual way that we have for carrying. Okay, some things that I've discovered. Start easy. One of the hardest things with designing and working with an IBL type of strategy is to make the problems close enough that the students can do it. And you don't want to make them too challenging that it takes them a week to do it. Usually I begin those classes by indicating, for you guys, I expect you to take maybe a half hour to do one of these challenging problems. Later on, my graduate students, I expect them to take a couple of months to do it. Challenging problems, but there's this differentiation. So start small and then build up, and here are some of the building up problems. Here's a problem, and it's given in terms of cups and quarts and pallets and boxes. How much milk was consumed at the high school? It looks like I figured it out. Okay, one of the first things we're going to do that they do with their students is construct the addition table. I started them on it. And construct the multiplication table. I put in these, and they know that 1 quart and 2 cups is 6 cups. So they can figure that out there. So that's what they have to do. That's their challenge. They have to fill in that chart. And it's great. So get them started on it. Once they get started on it, they really enjoy filling out the chart. All you have to do is get them to figure out one of these that has an extra digit there. And then once they get one of those, it progresses, snowballs. Okay, there's a good problem. Susie has a recipe for cakes that uses 2 cups and 3/4 of a cup for 1 cake. If she has 1 box and 2 gallons and 3 quarts of milk, how many cakes can she make with that much milk? Everybody knows that. Long division. I give them a hint. I tell them, produce the multiplication table for 23. I think I have a misplaced decimal point. No, it's 3/4 of a cup of milk. Yeah, okay, so you know why the decimal point is there. There's the arithmetic worked out. I am hoping that my workshop people that I'm working with this summer will be able to figure out this problem by the end of this week. In so doing, I promise you, they will see the problems their students have with long division and why it's so challenging to teach that. There's your solution. Next thing to consider are fractions. As it turns out, there are 16 tablespoons in a cup. I learned all these things myself. So that means to do fractions, we talk about quarter cups and tablespoons. And I make up some problems with that. So what's that mean? I've got an extra decimal place there. One thing that I discovered is that There aren't 4 teaspoons in a tablespoon. And I hope that one of my students or one of the teachers will ask me about that because they're cooking and they know the difference. So I tell them, that's a good problem. Let's figure it out. How much is a 1 teaspoon? 1 teaspoon is 1/3 of a tablespoon, so I'm dividing 3 into 1 tablespoon, and it's an infinite repeated decimal. And they're familiar with that. They know that 1/3 is 0.33333. And here's another one. You can play a little bit with it, give them an idea of repeated decimals. And I played with it a little bit. Some of them, I don't know if at this level many of them will catch this, but at least it's a start. 3 teaspoons is a tablespoon. 9/9 is 0.99999.
Sorry about all the back and forth, but we had a lot of different things to talk about. So now you want to prepare for the student's turn. So I consider myself the trainer, and then I have teachers, and the teachers have students. So as I refer, that's what we'll talk to. As you've noticed, I've put some toys on your tables. If anybody wants more toys, just raise your hand, and maybe we can bring you some more. Okay, this is what I do with my teachers, and I do this in a day. I have a day to do the pedagogy, I have a day to do a challenge, and then this is the culmination of the whole thing. A lot of my teachers are scared. Not only are they scared that it's not going to work, they're scared they're not going to be able to do it. All right, they're scared that their school needs lots of money to buy all these fancy manipulatives. If you notice, not a single one of these things is a manipulative. They came off my craft shelf for my kids. Okay, so they're all over the place. Basically, what's a manipulative? Something that you can touch and do math with? It does, but they think they have to buy the two-sided color, like two-sided color chips, algebra tiles. They have to have the squares for the ones place and the tens place, and they think they need the special stuff. So not a traditional manipulative, at home, around the house, over-the-counter manipulatives. Oh, I know they will. I know they will. This is why I like my cheap stuff. All right. So the kind of things that I want to do is I want them to be able to. We want to model IBL lessons for their students. I want to give them resources to find lessons for the different concepts they need to cover. I want to show them that IBL can be used in place of their traditional teaching techniques, because that's one of the things they think they have to do both. Okay, and you're never going to finish with both. Help teachers distinguish between lessons for discovering a concept and lessons which reinforce memorization. Show that IBL can be done with minimal special manipulatives, the very expensive stuff. And have teachers feel confident in teaching their own lessons. So that's what we're going to do. This is your job. And we're not going to be able to present here. Normally we'll present one of theirs, but you have all sorts of stuff out in front of you. Here's your goal. You don't have to use what you see. These are just basically as inspiration. If you see something around, it doesn't have to be on your table. You can go steal somebody's pink ribbon if you want to, and make up your own lesson. And I don't care where it's from. Let it be a concept that you're going to cover. For them, I give them their objectives. All the schools have their curriculum, and I give them their curriculum, and they start making lessons from that. I give them a lesson plan they have to fill out, and they have this stuff sitting in front of them. And you can work in groups. I'd say no more than 2 or 3 people per group. Trade off, get more stuff, and that's what you do. Okay. Not only are you making lessons for your students, but if you notice, we're modeling IBL at the same time. All right, so if I can pull you back, you seem to be having so much fun with your toys. So much fun. And this is getting really hard to pull you back. But for my teachers, it's a little bit tougher because they still have that anxiety that their students have, and so they'll be like, I don't know what to do. Use your imagination, So they all eventually come up with some. Some of them will go to websites and they'll say, well, we tried this last year, and so they'll pull something like the Legos and do something else. So I wanted to kind of show you one that I came up with. Okay, so mine was Who Killed Dr. G? I had this idea in my mind for forever of, ooh, Newton's Law of Cooling, like CSI, this would be awesome. And I got together with a high school teacher, and we came up with this big, huge thing, and we put her class on trial. So these are some of the evidence they got. We didn't use any of this stuff. They got alibis for their suspects. That worked with different concepts. They had to figure out, did they have enough time to get somewhere, so average rate of change. We gave them bank statements. They used that to figure out compound interest, because they had to figure out if the statement that said that so-and-so got paid so-and-so was exactly the same as what was left over in a bank account. And then we even did matrix transformations and translations to solve a puzzle where they can't touch it. They've got to be able to make it move with a computer. And then the coroner's report was basically what they were given to, write their information on. So we didn't give them Newton's Law of Cooling. We gave them this, and then they're like, had to figure out something on here will tell us when this person died. All right, and so this is that thing that I showed you about the teachers. Here's the things that the students say. I never thought I would be good at math. Though we didn't get to everything, I can figure it out. Okay, so these are just some of the things, transforming some of those negative ideas into the positive ideas that their students give to them and to us.
Of mine in the College of Education, and I believe that there's a difference between mathematics anxiety and mathematics teaching anxiety. We conjecture that there are some teachers who feel comfortable doing the mathematics at their level, but they're uncomfortable teaching it. So we've designed an instrument, and I'm asking for help from the community. We have an instrument, and we're setting up a Delphic process whereby we'd like input, we'd like people who are willing to read our instrument, to look at it and make comments on it as to whether or not they believe the instrument is actually doing what it is that we would like it to do. So some of you I've already asked, and there are others of you that I know, and I will come pounding on your door. If you are willing to look at this instrument and evaluate it, make some comments, I would love any comments about whether or not you even believe there is such a thing as a difference between mathematics anxiety and the teaching and the anxiety of teaching mathematics, which I think some of these people have. I don't know if there is a difference. That's our study. We want to try and determine if that's the case. Thank you very much.
Hi, I'm Joyati Devnath. I'm from Winona State University. I really like your approach, and I think the teachers will have a better confidence, and they will develop some more confidence in dealing with the students. But it still bothers me that to highlight when some of the negativity. If when they speak, teachers especially, when they speak something negatively, you just have to do, I don't know
I don't
how.
show that to the teachers. That was for you. That wasn't for the teachers.
Oh, okay, all right. Okay, then I don't have any more things to say. Thank you.
No, they would get mad at me.
So I definitely believe that there's such a thing as math teaching anxiety, although I've never called it that. How do you believe you would combat such things or address such things and help students through that anxiety?
How would we approach?
Yes.
How would we? My approach is to make the teachers see that that going through the same experience that their students have gone through, and see that they can successfully master by cups and quarts, then they should understand that they can pass on that same lesson that I've modeled this concept that I've modeled to their students, and I'm hoping that this will help relieve that. With our people this summer, we're actually going to do a pre and post. We're going to see if working through this module, and I'm probably just going to do the one, cups and quarts. I have another one for dividing by fractions, but I don't want to overwhelm them. And we're going to see whether or not that does change their perception. And that's our experiment.
So in your experiments, are you trying to alleviate their math anxiety as well to help alleviate their math teaching anxiety? Because I was wondering, is there a part where they actually get to practice the actual teaching part to alleviate the anxiety? Because a lot of times it seems like once you get to practice, you kind of like work out the bugs. I didn't know if that was part of it, or are you teaching them?
I hope I understood your question, but when I began the workshop this week, one of the things that my colleagues did is they had the teachers write up some of their concerns, and I went through and I looked at their concerns, and about half of them were things that I was hoping to address with my IBL example. And some of their concerns are things like, what kind of strategies can I use in the classroom to do carrying of digits, or to do hundreds and tens? And I'm hoping that with my cups and quarts, I'll give them some ways of looking at that. And my goal isn't so much to teach them how to do it in base 4. My hope is that when they see that there are different techniques for doing these things, they'll be able to pass those on and accept different techniques from their students.
Do they practice teaching? Do they practice
Any more
teaching?
questions?
Oh, these are already teachers.
No, but do they practice it?
Yes. We have 20 some odd teachers and 100 some odd students that are coming into the workshop. I get them in the morning, and then the teachers get their students in the afternoon. So they're practicing right away. I'm half deaf, which is why she's translating for me.
When you mentioned these two kinds of anxieties, it made me wonder if there's not an analogous situation in perhaps medicine, the difference between practicing medicine and being a teaching doctor. And I wonder if you've looked at anything like that.
Analogous situation.
Analogous situation with things like practicing medicine.
Oh,
teaching
I
medicine.
would not be surprised.
Yeah.
Yeah, I would.
So there may be something there.
I would not
to
be
look at.
surprised at all. Some of the instruments that are used to measure math anxiety I've looked at, and I'm worried that some of them aren't really measuring mathematics anxiety. I think they're measuring testing anxiety. Because when you go and look at these things, one of the questions is, I don't like to take tests in mathematics, but never on the instrument did they ask them whether or not they like to take tests in history or English. I think it'd be important to put both questions on the instrument, and we're attempting to do that.
Michelle again?